Hello, everyone. Thank you for joining. Thank you for joining this workshop. My name is Faraz. I'm one of the co-organizers at the MLOps world. Just before we begin, if you have any questions, please feel free to ask them in the chat with the Q in front, so that Mohamed can address them as he's going through the workshop, or we'll save them to the end. Also, just a reminder that the talks are actually hosted on Hopin tomorrow. You would have received an email with the access. If you have not received them, please send me a message on Zoom, and I'll make sure that you get access for the summit tomorrow. So without further ado, it's my pleasure to introduce Mohamed. Mohamed is a result-driven data science and MLOps specialist with 8 years of experience in machine learning and deep learning, and system design concepts, understanding data architecture concepts, data modeling, project design, and project implementation. This trilingual consultant has a very wide range of project experience in various industries. He was also the director of data science and AI at a startup in Montreal, and is capable of supporting all organizations in their AI ML project implementation. He's also the author of a book, Data Science Pocket Guide, that is also available on Amazon. So welcome, Mohamed, and over to you.
Thank you. So welcome, guys, to this session. It's probably around 3-hour session, so get yourself a snack and get ready. We have a presentation first where we will talk about some concepts. Then we'll focus on our use case of today. Then we'll move to AWS to start coding. I'll share with you by that time the hands-on workshop documentation that you can follow, including GitHub code and everything. As well, you'll be able, basically, if you want, you can code and develop at the same time that I do, or you can decide basically to do it later and focus on listening and then asking questions if you have some. So thank you for this introduction. We have a couple of requirements for this workshop. It's a bit of a technical workshop. So if you're not familiar probably with Python or with concepts around Kubernetes and so on, you might get lost a bit in the content. That's fine. At least you'll have access to the hands-on tutorial documentation that you could follow later after doing deeper research on potentially technologies like Kubernetes. So we're going to skip the introduction. He talked about my book available on Amazon called Data Scientist Pocket Guide. And the role of this book is really, at the beginning, I wanted obviously to do a hands-on book, so really with code and so on. But I decided to focus more on concepts. I decided to go deeper in concepts and explain how concepts work. For example, how random forests work, what does it mean, what's under the hood in different algorithms or concepts. You have over 600 concepts that are covered within the book. So yeah, I run basically a consulting shop, and we support customers in a bunch of different things, including MLOps. Our approach to MLOps is basically analyze, design, implement, and coach. We completely understand that today it's hard in the market to have proper resources in MLOps. I mean, if you want to specialize in MLOps, you're more than welcome, because today there is a huge shortage in the market. Very few understand what it is and how to practically implement machine learning lifecycle management within a company. This is something I usually share with partners and customers, is how to define an efficient MLOps architecture. It starts first by defining what is the level of expertise in MLOps do we have or willing to hire. This means that, for example, if you already have DevOps people in your team, that's usually a good start to at least have people that will cover the DevOps portion within your lifecycle. Obviously, machine learning engineers are a very important profile in the equation, because they are the one that does that do the bridge between development, experimentation, and production, especially from a practical aspect of putting a model in production, not just managing environments, because usually managing environments can be a task performed by DevOps teams. Another important question to ask is what type of inferencing machine learning are we looking for? Are we in front of an inference that requires microservices? We talk about streams. Are we talking about scripts or scoring against the database and so on? Then important to understand how many machine learning projects do we have in line for short-term, mid-term, and long-term. The pipeline, the load of your project pipeline is very important, because I've seen that case where companies, they implement 1 and 2 microservices in the link, and then they're like, okay, that's fine, we did our MLOps, that's good. But then they realize what they implemented is just not scalable. It's good, anyone can deploy for 1 or 2 projects. But what can you do when you are facing like potentially 1,500 or even more like deployed or ready to be deployed machine learning model, which can happen in different businesses depending on the industry. Then you need to understand what is the trade-off between automation and resource scalability. Automation is really the Rolls-Royce in any ops practice, where the idea is to look for opportunities of automation. If possible, obviously, a lot of tools can support you doing the automation portion. And then as well, very important to take in consideration is the resource scalability. And we're talking about human resource scalability. How many people do I need if we increase our loads of project and we have to put in production? Is my model and system offer me the ability to scale my resources, my human resources in an optimal fashion? Then something very important, and this is usually something I got like a good discussion with customers. Usually, it's either open source or either enterprise. Sometimes some companies, they like having both, because they see that enterprise covers 80%, then the 20% left of the environment is covered by open source. Some, they are just 100% open source shop, so they don't want any commercial solution. They would look more for open source solution. So really depending on the company, typical vendor, some companies are more 100% AWS, other 100% Microsoft Azure. So all this as well makes an impact, have an impact on the architecture that you'll be building. Oh, and that's the last point, but not the less important, is the data science team following the state of the art when it comes to source coding and versioning. A lot of time we spend in MLOps is time spending refactoring code, refactoring data scientist code, making it ready for production. And sometimes data scientists, they might develop something that is completely out of the box, that is completely uncommon and unusual, that is actually not suitable for production. So you need to have proper communication, like a bridge with those teams to be able to make sure that they understand what are the production requirements. And they have to keep in mind always the production environment and the production requirement. And you need to be there to say, hey, this is what actually we expect from a production side. This is the constraint we have from a production side. And they have to take that in consideration when building their machine learning models. So some architecture or design, here is a typical design environment that is 100% open source based on tools like MLflow, Kubeflow, Grafana, Seldon, hosted on Google. This architecture is inspired from a live architecture deployed at a customer, e-commerce. They use recommendation systems, and here they deploy the recommendation systems within this environment. So we have a scalable environment with portions of it that are automated. Like, for example, moving a model from the model registry to the model serving. another type of architecture. Here it's a stream environment, design environment. So here we're facing an environment that basically relies on IoT data as input data. And here the idea is basically to score the data and be able to detect any anomaly from the data. Again, here, this is an offline model, trained offline. So it will be basically updated every time there is a new model that has a better performance that beat the defined threshold. Some technologies and tools. I mean, I'm working right now on an internal project where we want to develop a database. We would like to do a tool review. So basically, take every software that exists in MLOps, either open source or commercial, and do like and build up a database that will basically do the review of every tool. The idea is to give a better picture of people of which tool, what can you do with the tool, what's its limitation, its good points, bad points, and so on. Yeah, because to be honest with you, in the field, there are so many tools, and every quarter you have new tools that are available on the market. So sometimes I understand that it's hard to catch up and be aware of all the solutions. That's why usually in MLOps, when I hire either machine learning engineers or MLOps engineers, I care less about the tools they know, more about the knowledge and their coding skills. Because the tool is just a tool at the end of the day. You can have another potential tool that will do the same thing, and you'll have like a very smooth learning curve to adapt yourself to a new tool. So MLOps 101. I got a question. I like to keep my sessions a bit interactive. Let's start with a warm-up question. So for you guys, what is MLOps and why is it necessary? Let's see if we can ask someone. Maybe let's see if Daniel Oltonu. Daniel?
Yes, hello.
Hi.
I'm actually a master's student, and we're trying to deploy a machine learning algorithm that we published onto a cloud platform for other researchers to be able to classify genomic sequences. So that's kind of why I'm here. So I'm really kind of trying to learn about MLOps.
Okay, and for you, what's exactly what definition would you give to MLOps? And why is it necessary in your opinion?
I guess the definition would be being able to update machine learning algorithms to the production code that will serve the actual web app, and it's necessary to make sure that the end user web app is always running and there's no fatal error on the production side.
Okay, that's good. Thank you. So I would say, if I have to define MLOps, machine learning operation is basically the management of the life cycle of machine learning. In it, you have the ability to take, like Sanjay said, to take code to production. Like Marina said, building production ML pipeline. It is needed to transfer ML experiment to actual tools that help the business. So a part of it is moving to production, but it's as well knowing that it's managing the life cycle. So it includes as well like managing the environment, so the development environment. MLOps practice decide and manage, maintain, and take the responsibility for the development environment. For example, if we are in an enterprise environment, we are the one that decides because in enterprise environment, libraries that you can import are restricted. So MLOps build like a list of access to the specific packages and libraries that you can call from Python or R or so on. So that's a part of MLOps as well, because you manage the operation of machine learning. So yes, it covers the production. This is the main function, being able to move whatever comes out of development to production, but as well manage the environments, including the development environment. Why is it necessary? You have to know that based on the statistics, I've been reading that on Forbes, it says that 80% 87% of machine learning projects are just failure. They never go to production. They just stay at the development stage. Why? Because of a lack of MLOps, because no one has either the expertise, the energy, or basically the vision to say, hey, we should focus on machine learning operation as well. I rather have an efficient MLOps practice than having with an average or weak data scientist practice instead of having the opposite. Just because moving the production is the key at the end. Because if it's not in production, like you said, Marina, it doesn't help the business. And between you and I, if you're looking to specialize in something that will be big in the upcoming years, that you want to be in is basically MLOps, because there is a shortage of resources. Not everybody yet understand how it is useful and what does it do exactly in a company. But in the near future, it becomes something very valuable for companies. I'm selling you the MLOps, and I'm telling all of you to specialize in the field. That's awesome. Good. So, yeah, and again, like I was saying, MLOps is not just about deployment. This is very important because sometimes people, they misunderstand. They think that we do only deployment. Look, I work with a bank as a consultant, and the majority of the team that I work with, and my role is not just production. We draft best practices when it comes to data collection. We build up like orchestration services. We configure environment. We work on as well monitoring the machine learning models. Very important in production. We brainstorm and talk about the infrastructure and how can we make it efficient and potentially save money for the company and so on. So all these are subjects to be covered in MLOps and to focus on. That's why it's even harder than being a data scientist, because it requires even more expertise from other fields. They say data scientist is a matter of business, communication, mathematics, and coding. Well, add up those four. In MLOps, you have those four. And in addition to that, you have DevOps, sysadmin, and so on. So it has a larger scope, because you still need, in MLOps, you still need to understand the machine learning. You still need to understand how algorithm works, what's the dynamic, and how data scientists, they work, what their code means, because you have to refactor the code. How can you refactor a code if you don't understand what they do with it exactly? Yeah, so a simple way as well to see MLOps is like, you could say that it's like DevOps, but for machine learning. We have three main components. Yes, it is a hands-on workshop, but we have time. We're still in for another 2 hours and 10, so we'll see the rest, but I obviously need Ronnie to do an introduction because we're not on the same page, all of us, and I want to make sure that everybody's on the same page and that we're talking about the same thing. We have continuous integration, continuous delivery, and continuous training as well. Based on my experience, I would tell you that continuous integration and continuous delivery is always hard to implement, because depending on when it's use case focused, for example, you have projects that have different dynamic inside the company. One is related to a recommendation system, another one is I don't know, a customer churn, and another one is IoT. Each use case brings new challenges for you in the continuous integration and continuous delivery process. Awesome, Kubernetes. So Kubernetes is basically a must today in application deployment. Basically, you can deploy almost whatever you want on Kubernetes. So for those that are not familiar with it, just basically, to explain it in a simple way, it's just a cluster, so a virtual cluster that will basically help you deploy isolated application with their own operating system, own application underlying. So you could have on the same cluster an apps that run on Ubuntu, another app that runs, I don't know, on Python Alpine, another app that runs on something else with different installation, different configuration, and so on. And one of the amazing things with this technology, it's its ability to scale. It has auto scaling functions that you can have in it. So with load balancing as well. So every time you deploy an app potentially, and you have a certain load in it, it would scale based on obviously the true infrastructure or resources that are available. But you have that ability to scale automatically with Kubernetes, building up configuration to deploy your applications on it. If you're not, again, familiar with this, that's fine. You can still survive our hands-on workshop. I'll invite you to dig in a bit, because this is some serious skills you need in the MLOps world. In the machine learning operation, you obviously need to master Kubernetes, because you will probably be a reference inside the company. People, they would ask you question about it, and you will have as well to build up code to deploy application in it. So Kubeflow is actually a great tool as well for pipelines, automated pipelines that is 100% focused on machine learning. So it has been deployed for machine learning purposes. It has other functions. So technically, it's a toolbox. It is a toolbox that can come with different tools like Celdon. You have as well Argo available on it, and so on. You can have Jupyter notebooks on it. TensorFlow can be available. And inside this toolbox, they have a tool called, or a solution called Kubeflow pipelines. And with Kubeflow pipelines, we will build today our pipelines and be able to basically deploy retraining machine learning model. If you know, if I am always agnostic, so if you're looking for an alternative to Kubeflow, look for something called Airflow. Airflow is very cool as well. It's an alternative to Kubeflow, and it gives you the ability as well to create pipelines. But here it has not been developed for machine learning specifically, so it can be used for ETL pipeline for machine learning as well. I would say that the learning curve of Airflow is a bit higher than the learning curve of Kubeflow, just because Kubeflow, its SDK is easier than Airflow. Our use case. Okay. Any questions so far before I move on to the use case? Okay, that's good. So our use case is based on Reddit data. So basically, certain time ago, Reddit wanted to be able to extract or basically identify content that is inappropriate. Within subreddit, if you're familiar with Reddit, within a subreddit you go, but you will have always people that can post garbage or post, what I mean by garbage is posting inappropriate content. And that's what we want to detect, because today it's done by a human. Basically, we have a moderator that will check each time every subreddit or his subreddit, and then look for inappropriate content, and then take that content and basically flag it. Here, we would like to automate this process to increase customer or actually user experience on Reddit. We would like to have a machine learning model that could potentially detect any inappropriate content from Kubeflow. So we will be able to detect with a degree of performance here any content that we might think should be flagged. And then probably we want to keep a human in the loop, have a moderator with less load that could potentially check for if the flagged is really like in inappropriate content. But here, knowing that it relies on an automated process, it will be faster. So the idea here, and that's the magic of this workshop, is we will move from a notebook. So from a notebook delivered by data scientists, we have refactored code. Then we have components of pipelines that are image-based. Then we have our pipeline, and then we have our deployment. And this is actually explained here in the architecture. Everything runs on Kubernetes, so it's scalable. We have our Reddit feed. We have basically inside our pipeline, we have a data extraction tool. Here, obviously, for demo purposes, we relied on a CSV stored, but knowing that I use the environment variables, basically, we just change the environment variable and it will potentially point to somewhere else that can be a live feed or so on. Then after we have the data pre-processing, then we have our classifier building. And when our classifier building is done inside our pipeline, that is automated, it will trigger deployment. This triggering, basically what will happen is it will take the model from the model registry that has been saved by the building classifier component, and then send it to production, send it to deployment. And in deployment, we already potentially have a model here that is deployed. So it will replace the existing model automatically by redeploying a new one. And keep in mind that when we deploy a machine learning model, we don't deploy the model itself. We want to deploy as well the pre-processing. Makes sense, right? Because to get proper input, as it was the case for training, you want to make sure that your data pre-processing is included. Here we deployed in advance from the first pipeline, we deployed the data pre-processing, and everything is in microservices. So the data pre-processing is one, can be considered as one like pod potentially. And we have our inference model as well. So they communicate between each other with Seldon doing the orchestration, and our model inference will output potentially results to the business. So this microservice could be connected to or have an integration with an application front end or so that you could potentially gather model result and look for inference. And any time we have a new model from our pipeline that is being pushed, we don't need to update the endpoint or the integration or so on, because it automatically updates the same, let's say, microservice that we have. So you end up just like having a new model with no downtime. So there is no downtime, no management here. It's really an automated process from this end. Any questions so far? And by the way, the pipeline here is triggered on schedule. So it can run every week, month, day, hour or so. And every time, again, if we redo the flow, every time we extract data, pre-process, automatically build classifier, then send it to the model registry, then we trigger deployment. And after the deployment is triggered, the model is fetched. Our model registry here is S3. Can be here a persistent volume, but I believe that I use an S3 in the demo. And then it will be sent to inference, where we have no downtime. So you have a rollout of the image, and the new image is being used for the microservice without any downtime. Marina is asking, where Reddit data comes from. No, not from the API. I use the CSV data containing the data stored in an S3 bucket. But and here it's I use the variable environment in the pipeline, so you could change the CSV to any other data source. But we could as well have been doing like an integration with the API. Is there a different data pre-processing component in inference than the first one? No, this data pre-processing is the same one as this one, obviously, because if you're training with specific data pre-processing in production or during inference, you need the same pre-processing. Wouldn't we want to trigger deployment based on precision, accuracy metric of training, whether or not it makes? Well, yes, we could, because you have two ways of triggering. Either you trigger on schedule, or either you trigger on on precision. But here for demo, knowing that I'm not scoring anything here in production, doesn't make sense to have it to build up triggering based on precision or accuracy or performance. But yes, it's possible to trigger on performance as well. But it's more complicated to set up because you need to set up basically here you need to have performance collection. So you can collect performance, then you have potentially a Jenkins here that will potentially take the data, crunch it, and then send it back to another pipeline. And this pipeline does the evaluation of the performance and then potentially send a trigger to the original pipeline that will do the retraining. So yes, it is possible definitely to trigger on the performance. What does the pre-processing microservice do? This one actually pre-process the data. So it will take the data and manipulate it. For example, here we have here we have text. So its transformation on text can be bag of words, that can be PCA, can be any transformation that you want to apply to the data. Why? Because here we trained doing pre-processing. It means that we have to pre-process before inference. So here, this component is the same one as this one. Yeah. How to trigger retraining for model drift in Kubeflow? Well, like I said earlier, if you can trigger based on performance, it's more complicated to set up because here you need to collect. You need to collect, sorry, you need to collect production data. So all the meta that comes from here has to be collected. And then here you'll have like an automation tool that will drag the information and then feed a pipeline that will potentially pre-process this data and then see if the performance is under a certain threshold. If it's the case, it will re-trigger this pipeline that we have here. Yeah, to answer your question, yes. Yeah, it will pre-process the data in not in the API load, but it will take it will take the original data that comes from the integration, so that is submitted, and then it will basically do the transformation on it, then send it to the inference model, and this inference model will return a result. So you have an orchestration here that is done from our machine learning engine in production. Any other question? Okay, so now we will move on to the use case. I will share with you a link. This link contains the workshop. It contains notebooks, everything you need to perform the workshop by yourself or by following what I basically would say. Please have a look at it. It's on the chat and tell me if it's all good. Awesome. So let's move on to the workshop. I will have my AWS account ready. So data format between the data preprocessing microservice and data preprocessing in retraining pipeline can be different, right? Hence the code could be different, basically doing the same thing across different forms of data. Well, the only logic, you could potentially have a code that is maybe more optimal or maybe a different library for any purpose. But at the end, it has to perform the exact same manipulation because that's how machine learning works. If you want to predict on data, you need to pre-process it the same way you pre-process. If you're normalized, you have to normalize again when predicting. So in production, you have to normalize as well. So if you do any transformation like PCA, you have to do it as well when you predict. So that's the only rule. At the end, if your code is different, that should be fine. It was more suitable for me to reuse the same production code, the same code in the pipeline, the same pre-processing code, because with that it's easier. Actually, I create an image. This image is used in the pre-processing in the pipeline, and this image will be reused in the pre-processing in production while doing inference. By the way, I worked a lot in this workshop on an image base. The components of the pipeline are images. The deployment module are images. And I believe image approach in MLOps is a state of the art. Work with the gaming industry recently, and we are working on an image-based for a lot of things, including deployment of the application and so on, which actually changes your life because you don't have any more versioning problems, problems with compatibility for libraries and so on. So all this is less, becomes less a problem working on an image base. All right, so I hope all of you opened the hands-on material. Now we will move to, basically the first step would be to create an AWS account if you don't already have one, okay? I'll let you do that either now or later. After that, basically we will connect to our account as I am connected here. Then I'll look for Kubernetes. By the way, here, a little tip, guys. I know when you work on Kubernetes here, it might sound like super easy, smooth, click, click, click. But to be honest with you, Kubernetes is among like the top complex technology that are available today in the market. It's easy because it's a managed service that they offer you in the cloud. But in reality, it's very hard to configure, very hard to maintain. So it's not an easy business from really, not as a user, but more as a person that will maintain a Kubernetes environment. That's good to keep in mind. In case one day you say to people, hey, it's easy Kubernetes, it's not the case. Okay, so now let's create our cluster. I'll name it MLOps world. Here, you would have to create a cluster service role. This will allow and give access to other resources to Kubernetes, especially things like EC2, because Kubernetes rely on instances like EC2. So here you should click create role, then select AKS, which is, then you select AKS cluster, then you click next. After that, you should be good. So you click next, then review, then you give a name to your role, whatever the name is, then you click create. After that, you should refresh here and you would see your cluster service role available here. Now we will click next. All the rest have to be kept default. This takes usually between 5 to 6 minutes. So meanwhile, I could answer anybody question. If you have issues right now logging in or so, let me know as well. We could potentially help you start a cluster. By the way, this workshop can be performed on any cloud provider. So if you work, or even locally, if you have access to a Kubernetes cluster locally, or you could do it on Minikube on your laptop. That can work as well. A Minikube will help you create a local setup to deploy Kubernetes applications. Oh, I can give you as well a good story. Like we were talking about. Oh, someone has a question. Do you use on Kubeflow for both dev and production, or is Kubeflow only for production when pipeline is finalized? Well, you can have them for both. But what do you mean by dev? Do you mean like data scientist development, or you mean by that like a proper development environment for okay, no. Well, it's, what's the purpose of having it for dev? I mean, it creates pipelines. So why a data scientist would like to create pipelines, except if it's ETL pipelines done by data engineering, that can be doable on Kubeflow. But data scientists, they wouldn't necessarily need to have pipelines. So I would say I would use it for pipeline focused tasks. So anything that requires a pipeline. That would be my answer. Ronnie says, I use Kubernetes extensively, not really familiar with Kubeflow. Can you please recap Kubeflow in a nutshell? So very quickly, Kubeflow is a tool for building up automated pipelines. Main focus is on machine learning. What I mean by pipeline is every automated process where I train, for example, my machine learning models. That's a pipeline. Or a pipeline can be me doing transformation of data or doing ETL on data. That's a pipeline. So that's the purpose of Kubeflow pipelines. Kubeflow as a set, and Jules, I'll show you later in the demo. Kubeflow as a set is a toolbox that brings all sort of open source tools that you can use. So when you install Kubeflow on deploy Kubeflow on Kubernetes, it will come with a ready to launch application like Celdon for deployment and so on. And inside, within those tools, you'll have a tool called Kubeflow pipelines. Marina, I'm sorry, is asking, after I click create role, what service should I choose? Create role, that's a good question. Where are you? Yeah, after clicking create role, you look for AKS. I'll write it in the chat. You look for AKS it's detailed at the stage 7. Maybe not well explained, but you look for AKS, and then when you click on EKS, you should have one of the options is EKS cluster. Then after that, you have EKS cluster. How is it different from scaffold? Well, scaffold purpose isn't the same as Kubeflow, because Kubeflow will look more for creating like production pipeline or automated pipeline. So I would say they have some kind of things that are similar from one another, because it still helps continuous development as well, where Kubeflow pipeline would focus more on continuous delivery. That would be like my answer for that. Any other question, maybe? Waiting for the cluster to start. If you would ask me what's the most difficult thing in MLOps and making MLOps a success, I would say collaboration would be number one, because collaboration in a way that you need to have great communication channel with like data scientists, but as well with business lines and so on. And sometimes you're very back end as well, because the main people that will communicate with the business lines are data scientists and not MLOps people. So sometimes you would feel a bit of like left behind in communication. So it's always good to set up like good communication channels. That's, if you have that, at least I believe that's a healthy practice that would give you like more chances to succeed. And another thing that is very problematic is, and hard actually, I would say, is the ability, well, usually you have a lot of different use cases. You end up, when you get in a company and they tell you, hey, we do data science or machine learning only for a time series forecasting. For me, that's a done deal, just because it's one type of use cases. So the scenarios or the type of scenarios for production are narrowed, so you know what to expect, so you can build up an efficient architecture. But when you come up and you're discussing and they tell you, oh, we do have IoT project related to machine learning, and we have forecasting, or we have recommendation systems, so you end up each time having more and more scenarios that you need to include, which actually complexify the architecture, and I would say increases the risk of failure as well. So it's more hard by that time. 2 questions. Do you have any best practices for automated testing? That's a good question. If I have any, well, you have like your unitary test, you have to build like test cases as well. You have load testing that you can do. So that depends, I would say, on the type of testing you want to do. But there are libraries. If it's like code based, you would have libraries that can help you manage your testing portion, I would say. Then second question is MiniKF versus Kubeflow. Well, MiniKF is for laptop, I believe, or like computer setup. So it's for you to run Kubeflow locally. Never used it, to be honest with you, because usually I create Kubeflow directly on cloud. But I would say that's a good start, at least, to have like the laptop version. Just have a look at what is included in MiniKF. What do they have exactly in terms of tools inside MiniKF? Another question is, how do you move between experimentation and production while iterating on a solution? Do you build multiple versions of a pipeline and compare them? How do you move between experimentation and production? That's a big piece. That's a big piece because, I mean, you have all the continuous integration aspects. So your data scientist delivering code, they have to version their code, they commit their code somewhere. I mean, a portion of it can be automated in a way that you can automate tasks from your repo, but you have as well the portion of continuous delivery, which inside of it, you have the pipelines. And that's as well, it's another piece. Do you build multiple versions of a pipeline? The answer is yes. Comparing them, I don't know, could be. Usually what we do is if we have an optimal version of a component of a pipeline, we update the image of the component, then we redeploy that image with the rollout, which means that next time the pipeline will run, you will have this new version up to production. So for someone who's getting started with MLOps, are there any resources that you can read? That's a good question. I would say if you go on Google, they have good documentation about MLOps. I think I can find you something about that. And Microsoft as well. Both of them, Microsoft and Google, they have good documentation. I'm going to send you the link. Yeah, that's the proper documentation. I think that should be a good start for you. And they have more resources at the end that you could access to. All right. Our cluster is active. So now that we have our cluster, we create the compute resources. I know that's weird. When you create a Kubernetes cluster on AWS, it doesn't actually create compute resources automatically with it. You need to create it by yourself, which means that your cluster is basically an empty shell at the beginning. So we will click on configuration, compute, then add node group. Let's give it MLOps 101. Here you'll have to basically create other roles. Very important because you need to basically include 3 roles. One of them is AKS worker node policy. The second one is EC2 container registry read only. And the third one is a CNI policy as well. When you create them, you could and create the role, you could update here and then select the appropriate role. So you see you have the 3 policies here. You'll have to create it by yourself, by the way, here by clicking create role. Then go on EC2. Next. Then enter the three roles that we have and select them. Awesome. And then click next tag, next preview, then enter the cluster, the role name that you want to add up. And then create a role. I want to introduce Kubeflow in my current company, working company, but I am not sure what type of resources are required and price of resources. What type of resources are required? Well, you'll need machine learning engineers because Kubeflow relies on Python for the SDK. I believe it's available only on Python for pipelines. As a toolbox, it's cool. It will require you, I would say, machine learning engineer, because they will have to build pipelines with the Kubeflow SDK. In terms of things that you can do, you could do ETL with it. You could do machine learning pipelines. For the pricing, it's completely free of charge. It doesn't cost anything. It's open source. And you only have to pay for the infrastructure and the resources that relies on. That's it. So you'll have to pay for the cluster where you deploy and any other resources. What to expect and what not to expect. What to expect is you'll have flexibility. You can deploy cool things. I mean, it's a tool with it's an open source tool, so you have a lot of flexibility in terms of what you can do. Keep in mind that sometimes I'll show it to you later, but sometimes the interface can be bugging just because the ingress, there is a problem with the ingress, so you might want to change the ingress. The second thing is user management. It takes like a couple of steps and it's not well documented. So you'll have to figure out how to set up user management on the platform. And you need to secure as well the access to the platform, because you don't want anyone to access to the UI of Kubeflow and look at your pipeline, obviously. So yes, it takes a bit of work from the DevOps side to be able to set up like a proper Kubernetes cluster that we can call like an enterprise cluster. Next. Here we would like, we are in T3 medium, that's good. We would like to set up like 6 resources, 8 maximum. So that's the minimum of the nodes that we want. Nodes are basically components of our cluster. We could consider them as the physical one, even if on the cloud they are still virtual, because you have so many layers of virtualization on the cloud that it's completely like, it's like in the movie Inception. But that's another story. Consider node as the physical, potentially physical clusters, physical like servers that you could have. We gave them like here a specific size, which is T3 medium. Maximum 8. So here we have the ability for a scale out, and we have a desired size. That should be good. Next. Then we click create. But I mean, again, and this is like a common discussion I have is, oh, should I go with the SageMaker or Azure ML, or should I use tools like Kubeflow? It's different dynamic, that's it. I mean, Kubeflow has flexibility, like open source tools, they have flexibility. They are more like hard to manage, obviously, and maintain. And you have no one to blame because it's open source. While when you pay for SageMaker, if you call AWS, you can blame them. I mean, that's the main purpose of paying money for that. But again, if you are a shop that will look more for open source, as a culture, you have that culture of open source. It's completely fine as well. It's just like it will require specific resources and expertise to do the setup. Do you rely on AWS SageMaker for debugging, or has some other integration debugging option with this architecture? I didn't include any debugging, and that's a good question. We could have something like CloudWatch for potentially looking for monitoring our application, our microservices, and so on. But obviously, this is not ready to reuse as is for production. There are other components we need to integrate. Like, for example, we need to integrate performance monitoring. We need to integrate as well. We need to integrate monitoring of like our health, the health of our systems, and the health of our applications, microservices, pipelines, Kubeflow. So all this has to be monitored, obviously. And you have all the security aspect of it that you need to make sure that your platforms are secure, that you don't mess up with the network like network options that you have. This is as well to be taken in consideration. Some of this doesn't have to be done by MLOps people. I mean, I rarely see, I never seen actually an MLOps person very expert in networking or in security. Usually we rely on other experts in the company to provide us that input, but at least we have like a base knowledge of it, a minimum knowledge for those aspects. All right, we're in business, guys. Our cluster is ready. So now I could create like Cloud9. So I'll go on Cloud9. Cloud9, what it is, just like an ID. Is there MLOps for deep learning? Yeah, obviously, MLOps covers deep learning actually. MLOps, machine learning operation, should cover deep learning, except that deep learning can be a special beast because it has special requirements. So it can have specificities that you don't have in other type of machine learning. And I would say almost every project can be unique in a way or another. Every project has its own requirements sometimes for production. So yeah, Cloud9 is an IDE. We rely on it to basically develop and submit code. Just because if I decided to do it on the laptop, that would go crazy. You are almost 40 people in the room. Imagine 40 people with different configuration of laptops, how crazy it would be to just like make sure that it's working for everybody. So the best option was to decide to go with a unique same environment, which is Cloud9. Yeah. It's here, you'll have to change the instance type to T3 medium. Keep Amazon Linux too. It's very fine. Next, create environment. Okay, here a little trick is we need more space. The T3 medium comes with only 10 GB of storage, and we need at least 30. So we will go on AWS, the console, log in. Then after that, I'll answer the questions after, guys, just finishing this one. Cloud9. And then I will go click on this, look for EC2 instance. And here we will look for the volume because it has a volume attached. So let's go under storage. And there you go. Here we have the volume. And like you can see, it's a 10 GB. We will modify the volume for 35. Yes. Good. Now we'll enter the code in the section 6, which will allow our storage to be available. Now let's look at it. Pretty good. We have the additional storage that is available here at 27 GB available. That should be good enough for our workshop. So the question was, what's the typical stack you recommend for serving infrastructure? By serving infrastructure, you mean like model serving and the different potentially stack that can help, like Flask. You have Fast API. Then you have like an ingress that you could use potentially. You have so many of them, so that depends on what you do. But the most popular one are the one that you just cited, basically Flask, GUnicorn, and James. You have as well Fast API. And depending on the language that you use, you can have other things than Flask potentially. But yeah, I mean, that's good, good stack that you can potentially use. Okay, so after that, we will install kubectl. kubectl is basically what allows us to interact with Kubernetes cluster. Obviously, we need the command to be able to interact with our cluster. So we'll download and then install the command. After that, we need basically as well like an authenticator for, because right now, even if it's on the same cloud, Cloud9 shouldn't be allowed to communicate or interact with any other resource. Okay. EKS control is specific to like EKS-CTL is specific to AWS. It's not a mandatory here, so I just installed it because I usually install that stack by default. Then we have Kubeflow control as well, which could be used and will be used with Kubeflow. So now that we have this initial setup performed, we should be able to start connecting with our cluster. To do so, we need basically to have an access key. To have an access key, you would have to go to My Security Credentials, go to access key here. And here, like you can see, I already have created one, but you could click on create new access key. It will basically download a CSV file called root key. And it should contain the access key and the secret. Forget about this. This shouldn't even be here. Just these two are your access key. So technically now you should be able to connect. So basically change the environment variables in step 6 when you open up the file. At step 6, you have the environment variables. Change the name for AWS key ID and AWS access key. As well, name of cluster should be replaced with the cluster name you have. The cluster name is available under Kubernetes service. You should have it right here. MLOps, mine is called MLOps word. Let's see what's the name you gave it. And now we should be good. Awesome. And now we should connect to our cluster. Let's do a little test. So kubectl get pods. Okay, no resources found in default namespace. So we're connected. That's good news. Now that we're connected, we have to set up and initialize Kubeflow on AKS. And I know all these steps for you are like, hey, why am I installing all this? That's the thing. If you want to get to pipelines, you need someone that can install them. It can be either DevOps, someone has to cover the DevOps flag and DevOps role inside the machine learning operation team. That's definitely mandatory. If you're looking for profiles, you need at least one MLOps people, depending on the load that you have in your team, but at least one person should be here available as the DevOps specialist inside your team, because you need people to do that. You need people to maintain that and so on. So here we'll create like a shell script called like kf install, which is just basically some command and environment variables. Oh, there is a mistake here. There you go. You need to change, by the way, name cluster inside this MLOps word. There you go. Yeah, that's perfect. Now we'll source the file. Awesome. Create a Kubeflow directory. It's right here on the left. The directory is empty. Then we will download the configuration file. Awesome. So here we have our configuration file. It's basically, like I said, Kubeflow is a toolbox. Okay. So, and in the toolbox, you have all sorts of tools. So here you have all the tools that are included. Some of them are basically things that Kubeflow relies on to be able to run. So you shouldn't delete them. I invite you to read Kubeflow documentation if you want to have more knowledge, but others can be potentially, you have Spark here, for example, Spark Operator, Jupyter Web App, Jupyter Notebook, PyTorch. We have Seldon as well, TensorFlow Training, TensorFlow Job Operator, Katib is included in here. We have Kubeflow Pipeline. We have database. Here we have persistent agent, pipeline UI, scheduled workflow, Seldon. Okay, that's good. So this is the configuration file you should modify. Make sure here, check out always the versions, because that's the thing with open source. You can give you feedback about open source. Open source sometimes is a mess just because of the versioning. When there is a new version that come up, basically it's not anymore compatible. For example, there is always compatibility issue between your version of the tool you want to use and the Kubernetes cluster, because they upgraded Kubernetes cluster version and your tool relies on another version and so on. So sometimes can be a mess. So make sure that you match always the version between one another. It will change the region here, West 2, I mean West 1, US West 1. Save this, awesome. Let's add up a policy here to the document. Here we need to make sure that our session can read the configuration information that we have. And then we'll apply the configuration file and deploy Kubeflow to our cluster. Here it should be running. Awesome. So now let's have a quick look at our namespace and the pods. Okay. So as you can see, all these resources have been created by Kubeflow. And that's why I was saying this is a toolbox. Inside of it, you have some that are used by Kubeflow itself. So they are necessary to keep them, like the LD ingress controller and application controller. Argo as well is used. The rest, some of the rest is just basically tools that are open and available to you. For example, here we have Seldon Controller Manager already installed. We rely on it for deploying our microservices. And we have our Kubeflow pipeline that is available as well. Now what we need to do is expose our service. Because if you go here, kubectl get services. Okay, here we have services, for example. Some of those services are needed for communicating with the outside. That's why we will set up here a load balancer. And the load balancer will come with an external IP. And this IP will be, address IP will be used to be able to basically access the interface. So if we copy this and we go to the web browser, it's not accessible yet. Usually it takes a couple of seconds or minutes for having the address available. Awesome. So obviously not secure, nothing is secured here. You can do the setup like you could do like more secure setup for your application and so on. So here, let's start here by giving it a name. Let's name it MLOps. Then we click on finish. Okay, now we have access to the interface. So interface here, very simple to use. We have here pipelines, the pipelines window with experimentations, artifact collected, execution, and archive. You have wearing the hat of being the data scientist as well as the MLOps engineer. I would say it's good because you're in position where people, they listen to you, but it's hard because people, they rely to you. So it's good and bad for the same reason. But still, it's intense as a job, but it's good because it's more paid than anyone else because you're in a unique position and people, they want to work with you. But at the same time, it is stressful. Sometimes people, they ask you very complicated questions from DevOps side, networking, security, and you have no idea. So either you need to figure out or ask the person that knows the answer. So, but yes, it's a lot of challenge. Then you have the portion with the notebooks. Here, that's cool. Kubeflow comes, this interface of Kubeflow come with notebook servers, and we'll start one of them. Then you have the Katib and the artifact store. So you could use Kubeflow as a model registry here, and then have your artifacts and the models as well stored inside Kubeflow. Now we'll start with the with the first case, which is actually we want to review our data scientist jobs. Okay, we want to have a look at it, obviously, because if we have to refactor, we need to look at the codes that they have been building. So let's start by creating a new server, name it whatever you want, simple. Yes, one space. There you go. You can upload custom images here. So if you have access to custom images, you could upload them. Here we have 4 that are available. Let's take the TensorFlow 2.1 CPU, not GPU, CPU. Keep the CPU and the RAM as is. Volumes here, we can add data volumes as well, which is a cool feature. So potentially in environments that you could have your data scientists develop on this type of environment where they could have access to GPU, CPUs, configuration, custom image, and so on. And from another portion, you could have the pipelines. So here they would develop, and from another side, you could have like the pipelines portion of it based on what they have done. Then we click launch. Takes a couple of seconds to launch. But at the same time too, I was thinking about it, Shizuru. I believe that being a data scientist and MLOps engineer for inside the same companies is not a position you want. You want to have good knowledge in data science and machine learning, but you want to keep your hat. If you are an MLOps engineer, you want to keep the hat of the MLOps engineer, because it's good to be a bridge, but when you are more than just a bridge and you play on both sides, it becomes too much pressure to handle, even if it can sound easy, because whatever you produce from data scientist side, you know what is the requirements from the production side, you do the refactoring. So at the end, you do all the workflow. So doing all the workflow for one individual is hard, even if that's the kind of profile I chase. because in large companies, they are usually very fragmented. So everyone will do something very specific. But people that I look for that work with me in my company is usually people that come from smaller companies, like startups, where I know that like the workflow can be performed by the same person. The same person that does the data scientist job will do the MLOps engineering, will be the machine learning engineer. So there are profiles that are more complete. So usually if you're looking for someone that is like the jack of all trades, it's usually in small startups that you will look for, small companies. Awesome. So we're ready. Now we click connect. We'll launch a new terminal from the notebook server. And here we will clone our my repo. Okay. So we click on Reddit ML pipeline, and then we should go under ML training Reddit. So now if you open data preprocessing, for example, you'll see the code that we need to refactor. So this is the code that usual data scientists they do. Here they import their libraries. Very important in MLOps to have tracking of libraries used, but as well their version. That's very important. And the environment where they were used, that's as well important to know. Here again, the type of data we have is a body text with a score, creation date, and then if it was removed or not removed. How much of time? Oh, Marina, we stay in here until tomorrow morning. Is that okay for you? No, I'm kidding. It should be done in an hour or so, not more than an hour. I was planned for 5 p.m., so we should be good. I think we're on time. I hope that's okay for you for timing. Worst case, you have the documentation, so you can continue working on. How much of time? I reused. I'm not the kind to reinvent the wheel, so I reused an existing code. I upgraded it, and I was able to build this, but it took me probably a week. But again, there is no security setup, no user management. It's very raw. But at the end of the day, if you want something more enterprise, it would take like, having proper resources. I mean, people in your team and so on to do like, a solid case ready for enterprise production. So this is the data we have here. Here they applied, obviously you can see that they applied transformation like TF-IDF. Here they started trying a logistic regression based on TF-IDF vectorized data. We have our confusion metrics here. ROC AIAUC curve, 1 score. Again, more visualization. They tried different models as well here to compare between them and get results. But obviously, knowing that it's text-based data, we could have multiple approach. I mean, we could have more using traditional machine learning, but here you'll have to work with either bag of word, then apply any transformation on it. Like we have TF-IDF as well that has been used, can be PCA, can be anything, and then score or build up a binary classification model to decide if it's or not like an appropriate content. Another approach would be to use deep learning, and with deep learning you could potentially be able to have less transformation on your data, and then be able to build up a model that can do the representation learning, and then be able to extract if it's or to score if it's inappropriate or not as a content. So TF-IDF is just because this is TF-IDF is a transformation that we add to the pre-processing. So the pre-processing that I showed earlier, that comes as a component and that we use in the machine learning engine for inference, includes TF-IDF. So basically, it will be a statistical measure that evaluates how relevant is a word inside the collection of documents. So basically, it counts how many time like a word appears in a document and the inverse of the document frequency of the word. Using this information, it will be able to compute a score for every word used. Here again, they tried the deep neural network. So they add up embedding layer. Okay, so this is basically a typical notebook that you can receive from data scientists. Now, convert it. There is two things that happen usually. Either you want to convert this to a deployment model, so you want to deploy it. So usually you would ask for a couple of things. You would ask for like a design of the flow for prediction, including transformation. You'll ask for the libraries. You'll ask for a JSON, Pickle, or XML, or Onyx, any type of export of your model. You need obviously the versions, and you need to know in the flow, in the workflow, what is the transformation that are being done. Usually we require to make it easy. Data scientists themselves try to factor their code and bring you a code that can potentially that does the inference, and then you refactor that code to make it ready for being used as a script inside the microservice. So that's it. The other notebook is as well EDA, so visualization that have been done. Obviously, if we had a tracking tool, if we implemented a tracking tool, we could have been tracking as well here the experimentation that has been performed, and but moreover as well saving visualization as artifact. So now we need to go back to Cloud9, and we will get back to environment and then clone the another repo of mine that will be used for basically deploying a pipeline for this case. So you could have a look at the original Python file, and in this Python file, you would have, we use the SDK. Here it's KFP, and it's it's the one that you need to basically create Kubeflow pipelines, because Kubeflow pipelines are created using Python. So here, basically, using decorators and functions, we'll be able to create our pipeline. Comes with components. You have two options in the development, high level. Either you deploy, you create components as function hard-coded within your script or within a module called by your script, or you have the option to create image-based components. So image-based components are better, I believe, because every component can be then updated easier, and every component is like separated from the others. For me, it's more clear and easier to maintain and manage. And obviously, at the end, what we do is we combine all the pipelines together into a second pipeline. Because we created, I'll show you in the interface, we created 3 small pipelines. And then we compile it as a YAML file from the Python code. Obviously, there are ways to communicate directly with your Kubeflow pipeline server, which will allow you to send and push your code to as a pipeline. But here we use the easiest option, which is basically compile it as a configuration file. Then what you will do is basically download it from the interface. Then we can go back to Kubeflow, go to pipelines. Then we come here, we upload pipeline. This is test 1, test Kubeflow. Now we upload it from a file. We go to download and we get the file. Click create. Awesome. So here is our three pipelines that we have inside one pipeline. We could click on create run. Okay, has been selected. That's good. Experiments. You see, that's the kind of latency you have with the interface. But based on the readings that I did, it's due to the ingress. So potentially, if you change the ingress, it should be okay. Is there a different runtime if we use a different image? If you use a different image or one image, basically, if you use one image, you'll get, well, that depends on how you structure your image, but potentially this one image can do the job for all of them. It's just the way I process this one is multiple image, one image for every component of the pipeline. But technically, it shouldn't impact much your runtime, depending on the way you optimize your image. So that has that makes actually a big difference. Then in terms of runtime, you can select recurring. Recurring is cool because here you can set up periodic or cron. So you'll have the ability to set up the maximum concurrent runs, the start date and date, run every day, minute, hour, week, month. This is cool because that's how you schedule your pipeline. And then let's click start. So why it takes time is just it's starting a pod. So when it starts a pod, it started on Kubernetes. So they are basically ephemeral pods that are started. So they are basically pods that are started temporary. You can see them here. So they start, they run, they complete the task, and then they're off. So that process can just initiating one can sometimes take time. So here, all our components have been run with success. Here, it gives you access to more things like the artifacts, potentially the input output, which help you track the volumes associated or volume mounted, the manifest, and then the logs. Here in the logs, I just print out random numbers. Same thing for the rest. Here, oh, I have printing problems here. supposed to go back like to a new line. That's not the case, but that's fine. It's still processed in the right way. So yeah, that's the like 101 case. This is just a warm up before our main case. And our main case would be basically to go back to Cloud9, and we'll get the other GitHub repo that I have. We'll clone it. This one contains the project that we have seen here and that we accessed here. Except that this time it will contain we had a look at ML training Reddit. Now we'll be focusing on Kubeflow pipeline deploy. Here we have our deployment. It contains a requirement file here for libraries. This is very important always, and versions are critical, because if something has been deployed on a specific version, nothing guarantees you that it will run in production on another version. This is usually the kind of things that MLOps people deal with. Not this one. Okay, I could show you the main NLP pipeline. So this is my main pipeline built with the SDK of Kubeflow, KFP. Here, my pipeline relies on mounted volumes to transfer data from one component to another. And then it relies, every component here will relies on an image. Here, it relies on image called data downloader. And the images are created from, if you go to pipeline steps, you'll have every component here on the left has its own script, and it has its own here we have a Docker file to build, basically very simple Docker file to deploy the microservices. We can look at the main script. So the main script here will basically read the CSV, so read the file, and then perform basic transformation from it, like being able to extract X and Y from it. And the same thing for every component that I have. I have a main file, and this is wrapped up as an image. And technically, knowing that it's an image, if I want to redeploy a new version like I did here, I can deploy the version 0.2 and then 0.3 and then keep going. And each time my pipeline will run, it will run on the version basically specified, or the latest version. That's a cool feature here. Same thing here, again, another component with its own image. And then basically here we do something a little bit tricky, is that we look for cell-done configuration file, because you have to keep in mind that our pipeline triggers cell-done. So it will trigger the microservice for deployment. So for that, we have a specific cell-done production file, which is a configuration file, and it has basically cell-done necessary configuration, including the cell-done. What is cell-done? Cell-done is basically an open source. It's an open source tool for deploying microservices. So this one is specific to, it's a company based in UK. Much appreciate working with them. And they are basically having an open source version of their tool that can be used to deploy microservices for machine learning specifically. So you can use it to deploy transformation. You can use it to deploy your models, whatever models you have, be able to predict and so on. And it has as well cool features like the ability to do A/B testing in production and so on, which is great as an add-on. So here, and this is the magic here, I reused, if you see this image here, msaber/clean text transformer is the same one that I used here. So basically I reuse the same image from the component of the pipeline to the production. So this image is reusable at the same time as a component of a pipeline and as a component of my machine learning engine to do prediction and inference. So here I specified what they call the graph. So basically the graph is the way you do the orchestration, because obviously keep in mind that every piece of my or every microservice inside my ML engine has to be orchestrated. So it has to communicate information to another service and then to another service. And this is why we use graph here. Graph will allow like spaCy tokenizer to take the data, then potentially output something and then send it to TF IDF, and then send it to LR classifier. With this, we have the ability to basically orchestrate information between 4 potential microservices that we have here. I know this I'm maybe going too fast. It might sound complicated. No worries. You'll have anyway the code. You have the presentation and so on. Follow the things. Do research on Seldon. Do research on Kubeflow, and you'll start feeling more comfortable. And anyway, you can reach me as well on LinkedIn or by email if you have additional questions. Okay, so now it's time to basically install requirement, because we should technically, the image, even if here the image are built, technically before uploading our pipeline to Kubeflow, we need to have pushed like our image. So they are available on Docker Hub or any other registry. If you use, you could use AWS registry for images or any other one. Here we'll do some installation for Python. So we'll install the requirement dev file that we had here, if you do remember. And after this step, we'll install S2I. What is S2I? I know a lot of new tools for you, but no worries, I'll explain them. S2I is basically, it does similar things than Docker. So it will build your images, except that here, why we use S2I is because Seldon relies on S2I images. So we need S2I for Seldon images. That's the main reason. But other files are, or the components that are not used in the pipeline, or not used by Seldon, but just by the pipeline, like for example, data extractor, could be built and is built only using Docker. So now we'll install S2I. Awesome. Now we should be good to build our images. So we'll start by, we have 5 images to build. So we will build them. So again, if you want to have more look at the way I build the images, look at the build image here that I have with the requirement file. And again, some of it are similar, are basically based for Seldon. So because Seldon is the module for deployment. But if we look at the, for example, data downloader, you'll have like a Docker file that is available. Here, the configuration file is called .s2e environment, and it's actually hidden. So that's why here we don't have any configuration file that is visible. It's because it's in a folder called .s2i. For demo purposes, I'm not pushing the images to my Docker Hub. It already has been done, but technically, after building those images, like written in the documentation, you should have to push those images to a registry or to Docker Hub. Okay, so build successfully. Let me show you now. Okay. And after that, we will basically compile our pipeline by running the Python main file. And the file is this one, by the way. This is the main file that we have located in train pipeline. Now we want to compile it. So to compile it, we'll have to run the Python file. There you go. Now we have here, if you see on the left, we have like a compressed file here. So this is basically our pipeline ready for production. We'll download it. Before uploading it, we still need to do a couple of things. And this is where it gets a bit tricky because we need to edit what they call a cluster rule. Okay, we need to edit cluster rule for a main reason is basically communication and our ability to have rules that limit the permissions of our resource are in. So you cannot communicate with whatever you want, even outside the namespace or so on. So you need to edit the cluster rule, and the cluster rule will contain the rules that represent a set of permission for resources inside your cluster. So if I want my, for example, Kubeflow pipeline to be able to extract images, or I want my Seldon to be able to run the inference and so on, I need to edit that. So here we'll edit it and help basically pipeline the pipeline to be able to communicate with Seldon. So here I'll add up a rule. Okay, it's all good. Now I can leave. Awesome. So it has been edited. And a little thing that I discovered, you can enable inference for Kubeflow, or actually for the namespace Kubeflow. So with this, we're capable of having like our service being able to communicate and run the inference from Seldon, because we want to have a microservice that can communicate outside and be able to send and receive information. Do you have any insights on the Docker container runtime removal from Kubernetes coming up in late 2021? I'm not aware of that, Ronnie. I'm sorry, I'm not aware of that that removal from Kubernetes. But if you have documentation, send it to me. I'm curious to see what it is about and what's the impact on what we're doing. Thanks. Now we can do a final check on our pods. So So everything seems to be okay. Now we can move on and upload our pipeline. This is Reddit Reddit 101. From a file, choose, and then we upload it. Now we can click create. Awesome. Now we have our pipeline basically ready. So here you can see that we have the complete pipeline that can be used or that can be run potentially. Oops. Okay, so now we could create yeah, good. Create the run, choose pipeline. So we select Reddit, use this pipeline. So you see here, sometimes you can have these small bugs in and the latency in Kubeflow. It can happen sometimes. Based on my reading, like I said, could be ingress problem, but you probably have to check it. You're welcome, Marina. Okay, run name test 4, choose experiment. I use default experiment, but again, your ability when you run here, you can potentially create own experiments based on what you're doing. You could potentially, it can be, I think, again, it can be used. You can use it for development. I think you can use it for development. It's just like not a common case because people, they tend to use it for production. But I believe the tool has been developed as well and more precisely for development as well, where you want to run a pipeline, maybe automated, maybe not, that will potentially run experiments. So it would be as well, can be as well used for development purposes, but it's really use case specific. So it's based on the case that you have. I see a good use case for development with using Kubeflow in development would be for time series forecasting. For example, you have 300 time series and you would like once a month to check for nothing in production, just to check for new models that can potentially improve results on a monthly basis. Well, then that's more a development side. You'll have your own little pipeline that will run experimentation on your time series to get performance level on it and see if they can perform well or not. Okay, now we'll do one off here. I have, because I enter it here in the configuration file, I have environment variables or parameters here entered. Could be modified. This is cool because if you have these type of things, if you work following these best practices, you will be able to modify a pipeline. For example, this pipeline is good for this use case, and I could reuse it for with other data set just by modifying here using the same pipeline, just modifying, for example, the input CSV or potentially having other modification performed or other parameters here that can be performed. So let's start the run and cross fingers. I have this little lag once in a while, quite frequently depending on the setup that you have. So this is completely normal. And again, there is an option to potentially avoid having these. Any other questions so far? Okay, so let's have a look at our experiment, our run. And by the way, a lot of open commercial solutions, they rely on Kubeflow. Just to sell you a bit Kubeflow as well, like if you go on a couple of commercial solutions, not to give a name, but they rely on Kubeflow. They use Kubeflow for pipelining. Some they have their own very own systems, and others they do rely on Kubeflow. So okay, our pipeline is running. It's not done yet. It's on the vectorized component. So you see, even if we have the lag, there is no crash. So it's just like lag in time due to communication issues. It's running. We have our predictors and our Seldon has been deployed. It seems to be good. So it means that it created a microservice or microservices. It should be good. Let me check another thing. Oh, it's lagging. Okay. You see the code is not perfect, potentially requires more fine tuning, but it's working, it's functional. So if we go back here and we click Kubeflow pods, we potentially can have a look at the deployments. So we are here, you can see that it's a new pods created called Seldon deployments, and they are up and running. So now the last steps will be to look for the ingress, because we want to basically call our microservices and be able to get information or get actually inference So I already sent like a text here, so I'll just copy this and paste it, see if it's working. Okay, so we have a response here from our deployed microservice based on our retraining pipeline. Here we have metadata. So this is a random UI generated, which can actually be stored as well to identify every run, every call. Here it has the routing. So with this, we're capable of understanding the orchestration, the request path as well, same thing. Then we have the data. So here, no inappropriate comment. Inappropriate comment, no appropriate comment. 0.67 no appropriate comment, and 0.32 inappropriate comment, and 0.67 appropriate comment. What we can do more, I'll open up my notepad. We could potentially just, some testing. We could change here the word to something more rough to see what's the actual response. We want to test as well the quality of our machine learning model, but this one is an easy case. So awesome. I'm sorry for the words, but I'm sacrificing my dignity for science. So let's give it another try. Okay, this one still detected 67% as inappropriate and 32% probability is appropriate. So I think we're good. Again, the pipeline could be run on schedule. So if it runs on schedule, the next time you will run it, it will basically look for update the model, create a new machine learning model, save it in a persistent volume or an S3 or whatever model registry you want, then trigger the deployment, either based on performance. So for example, if your model has a performance level in a pipeline over a certain threshold, it will push it to production. And technically here the endpoint that I'm using, okay, is not supposed to change. So we're not changing the endpoint. It will update automatically the model and we'll have the new model in production. It will do from pod perspective in a Kubernetes cluster, it will do a rollout. So you'll not, from user side, you will not see any difference. For them, there is no latency to that, nothing. So here we'll have like an efficient system that can generate prediction and be updated based on a pipeline using Kubeflow. The pros and cons of Kubeflow, very specific to Kubernetes, Airflow, border orchestration tool. Here is the link. Yeah, absolutely. I mean, it's hard. It's usually a decision that can come up between Airflow, Kubeflow. My experience is Airflow is good. It's very good as well. As a tool, is based on DAGs. And I mean, it can do whatever you want for automating pipelines and automating tasks on schedule. So you could run ETL on it, whatever you want. Kubeflow is good just because it's based on, it's really focused on machine learning first. Just for that, it's good. And it's have like other cool features, like the ability to have access to notebook servers, the ability to have artifact store and so on, which is actually cool features. Awesome. So me talking for almost 3 hours. That's awesome. Then we have Katib for machine learning. This is just this one here. This is basically a cool tool as well for hyperparameter tuning and neural architecture search. You could basically test it later at home and be able to perform whatever you want to perform with it in terms of hyperparameter tuning. It's based on YAML configuration file. So you'll basically upload the configuration file with images or with paths to your model stored somewhere in the cloud, and it will run machine learning. It will run hyperparameter tuning on specific models. So I think we're done with the workshop. So basically, I could take questions before ending up maybe last notes to the user. Oh, by the way, please, to avoid you any additional costs, when you're done, delete the cluster. And to delete the cluster, you need to start by deleting the compute resources. So first, delete the compute resources here. Okay, delete. Then you delete them. MLOps 101. And after that, you can delete your cluster here. And when you're done with that, go on Cloud9 and delete as well Cloud9 to avoid you again any additional cost. I don't want you to have bad experience with you and say, hey, because of this guy, it cost me $100. So any question or comment or something maybe you think I could do to increase this workshop quality? Okay, that's good. If no news, good news. That's what usually people say. So it's fine for me. You're welcome, Ron. You're welcome. More than happy. And I'll add up my LinkedIn profile. I'm very active on LinkedIn, posting every day about machine learning, MLOps, and so on. And you can communicate there with me in case you have additional questions or help on something. I would be more than happy to help. I work as a consultant. So I'm always open for business. You never know. But yeah, I'm more than happy. And as well, if you have time, I can send the link as well to my book, available on Amazon. I'm going to send you the link right away. There you go. Oops. Everybody. There you go. You have the link to my LinkedIn profile and to my book. And if you're new to MLOps and you're trying to figure out how to build up your career, I wish you a lot of luck. It's definitely a domain that I know will uprise because companies, they start investing in machine learning, and at a certain moment they start having like challenges with MLOps and with issues and so on. So definitely we'll need profiles in MLOps, like more machine learning engineers. For me, every data scientist should become a machine learning engineer, by the way, because that's a future of data science, having more machine learning engineers instead of pure data scientists. As well, more and more MLOps engineer will pop up. So we'll have profiles on MLOps, pure MLOps engineers. We can see some on LinkedIn, some job posts, but you will have probably more of them. Awesome. So if there is no additional question or comment, I think we're good to go. I'll let maybe Faraz, I don't know if you're here. Yeah, you could maybe take the lead on this to end up the session.
Oh, sounds good. Yeah. Thank you so much for, once again, for a very great workshop. It's always a pleasure to have you. Just a reminder to everyone, the workshop is recorded. We will share this after the summit, and then we look forward to hosting everybody tomorrow. Thank you, everyone.
Thank you, guys. Thanks a lot for your time, and I wish you a good end of the day.
Thanks, everyone. Bye, Mohamed.
Thank you.